All right. Hello, everyone. Thank you so much for joining this webinar. We're going to wait just a couple minutes while more people join. In the meantime, I'm going to share my screen. Hello and welcome, everyone. Thank you so much for joining me today for the virtual Geology of Alum Rock Park. I think this is going to be a really good program. We're just going to wait a couple minutes while everyone trickles in. My name is Michelle Garcia, and I'm the Educational Program Coordinator for the Open Space Authority, and I'll be the one who is leading you through this virtual presentation of the Geology of Alum Rock Park. Some of you may recognize me. I've done a few other programs at Alum Rock Park in the past few months. I also do lots of programs with the Open Space Authority. So if you are returning for a program, thank you so much. It's great to have you join me today. And if you've never seen me before, I hope that maybe this inspires you to join us for some programs in the future. All right, it's about 10:02. I think it's time to jump on in. So once again, my name is Michelle Garcia. I am the Educational Program Coordinator for the Open Space Authority. And today we are going to go on a virtual exploration of the geology of Alum Rock Park. Now, this is a Zoom webinar format. It's going to go from about 10 a.m. to 11 a.m. that I'm hoping there will be plenty of time to answer questions. As you enter this webinar, your video is off, so I can't see you and neither can any of the other participants, and you are all muted. So you are welcome to, get some snacks, sit back, relax, and enjoy the webinar. You can, of course, ask questions. At the bottom of your screen, you should have the ability, you should see a button labeled Q&A. And that will allow you to type in questions that are sent to me. I'm hoping to take a couple of breaks during the presentation to answer questions as I go. But if I forget to take breaks, because I sometimes do, I will definitely get to all of the questions at the end of the presentation. If you want, you're welcome to go ahead and try and find that button, the Q&A button, shout out, say hello, say, Michelle, you're gonna do a great job. Nicely done. And there's already a question. Yes, this program is being recorded and it will be available afterwards on the Open Space Authority YouTube channel. So no need to fear if you have to leave early or you're coming in late, this program is recorded. Thank you for asking that. All right, so let's dive in. Or before we get started, come on. Go to the next slide, please. What's wrong, presentation? There we go. I'd like to take a moment and acknowledge that the Open Space Authority works within lands that were originally stewarded by the Indigenous peoples for thousands of years. We want to honor Indigenous peoples and tribal representatives who work today to restore and protect their culture and connect to the land. The Open Space Authority manages a number of different nature preserves in the Santa Clara Valley area. One nature preserve that we manage is called the Sierra Vista Open Space Preserve. This picture is actually a view of the Sierra Vista Open Space Preserve. It is in the northeast part of San Jose, right on the edge of Milpitas. And it is those very tall hills up above San Jose. From the Sierra Vista staging area, there's amazing views of all of the city of San Jose, views into the East Bay of the San Francisco Bay, amazing sunset viewing, amazing raptors, great hiking trails, all kinds of cool stuff. You may be wondering, why is the Open Space Authority talking about Alum Rock Park? Well, we actually are partner agencies and we do a lot of programs together. And a big reason for that is because Sierra Vista Open Space Preserve and Alum Rock Park are right next to each other. In this map, you can see here Alum Rock Park in kind of a darker green in the very center of the map. And just above it, Sierra Vista Open Preserve is present. So Sierra Vista, it would be like the hills up at the very top of those mountains above San Jose. And Alum Rock Park is the valley down below, which is very cool, which means all of that hillside is protected land. And because our parks are right next to each other, our trails connect. You can hike all the way from Sierra Vista, the top of the hills, down to Penitencia Creek in Alum Rock Park. We do a lot of partnerships together and we love to support each other, which is why I'm here today talking about the geology of Alum Rock Park. Another reason we're here today is because Alum Rock Park is 150 years old. It was founded in 1872 and is one of the oldest city municipal parks in all of California, which makes Alum Rock Park really special. It has an amazing history and it has a really amazing rocks. Not only does it have hiking trails, but you can also, there's horseback riding, cycling, picnic areas, plenty of room for just relaxing. And it is within the foothills of the Diablo mountain range. There's over 720 acres of land in this park alone. So it's a great area to spend some time with family, to hike. I love Alum Rock Park because Penitencia Creek runs year round through the center of Alum Rock Park, making it really just lush and beautiful. There's tons of plant lives, there's beautiful trees, and that beauty isn't just for people. It's also for the animals at Alum Rock Park. I personally had seen great horned owls, red-tailed hawks, lots of squirrels, gray foxes, bobcats, deer, all kinds of amazing creatures live and depend on Alum Rock Park. So I'm very excited to take you on a little virtual tour on why Alum Rock Park is so cool. Now, part of the whole reason we're talking about geology today is because had it not been for the geologic events and the active geologic features in Alum Rock Park as we know it today may have never existed. So it's important to take some time to recognize the history and recognize all that this land has been through to be what it is today. So let's start off with the name, Alum Rock Park. If you've ever been there before, you might have found yourself wondering, who's Alum and why did they name the park after him or them? Or that's what I wondered when I was at Alum Rock Park. But during research for this program, I found out that Alum Rock Park isn't named after a person, it's named after a rock that doesn't actually exist in the park. So back in the 1870s, when Alum Rock Park was being kind of founded as a park, someone was hiking through the park and saw a large boulder in a narrow section of the canyon and said, oh, hey, that boulder is full of alum. Now, alum is a type of mineral often known as potassium alum, and it had many uses when mined back in the 1800s, 1900s. It's still used today as an antiperspirant for some people. And so it was thought that there might be valuable mining at Alum Rock Park. And because there's this huge boulder right in the middle of the park full of alum, they thought, hey, why not we name it Alum Rock Park? As further investigation went on and more people visited Alum Rock Park, they found out that there is actually no alum at Alum Rock Park, but the name stuck, and that's what we call it today. And in the picture to the left, you actually see what alum looks like in kind of a really pure form. I'm not sure which boulder it is in Alum Rock Park that they thought was full of alum. I know that most of the boulders there have a lot of amazing minerals like quartz and shale, but there's no alum in Alum Rock Park. It's just in the name. Another attraction Specifically, another geologic attraction that drew people to the park was the Alum Rock meteor. Back in the late 1800s, it was thought that this was a huge meteor that had landed in Alum Rock Park. And this was a huge attraction in the early days of the park. This meteor was this huge chunk of black, like smooth, silky rock, about 15 feet across, and was estimated to weigh over 2,000 tons. In the picture to the right of the screen, you can see the meteor, as well as a couple of people standing next to it. So you can see this thing is huge. It was nestled right in Penitencia Creek. Now, unfortunately, there were many people who did not believe that it was actually a meteor. Some scientists would say that it was definitely not a meteor, but locals did not believe this. There were many stories of people saying that they remember in their childhood seeing the Alum Rock meteor scorch through the sky and land at Alum Rock. There are also many accounts of locals saying that it's been there their whole childhood. It's been there since their parents can remember, since their grandparents can remember. So there are a lot of conflicting stories about the arrival of the Alum Rock meteor, including scientists and geologists have disagreed. Many scientists believe that this is a natural occurring boulder of manganese oxide, which is actually another pretty valuable mineral that could be mined at Alum Rock Park. Because of the presence of this mineral, there was actually a lot of people who wanted to mine at Alum Rock Park, who wanted to buy parts of it or lease parts of it to explore what minerals are present. And the city denied almost all of these claims to mine at Alum Rock Park. Many people tried to mine in the neighboring areas, but they were never able to find enough resources to make mining worth it or make it valuable. And so there's just this huge boulder of manganese oxide in the park, which even as, scientific word spread that it wasn't an actual meteor, people still came to come see the Alum Rock meteor because it's a really cool rock, and who doesn't want to see a huge, really cool rock? It must have been quite something to experience. I mean, you can see in this picture how large it is compared to these humans. Now, unfortunately, the Alum Rock meteor is not present anymore as we see it in this image. It was removed from the park and melted down to help with the war effort of World War I. I'm not sure what they used the rock for when they melted it down, but manganese oxide has a lot of different uses when melted down and reformed. So I'm sure this large boulder went to many different uses during the World War I. There is still a small chunk of the Alum Rock meteor still in the visitor center to this day. So as the visitor center opens, you can still visit to see a part of the Alum Rock meteor. It'll be this beautiful, shiny, black, smooth rock. And it's just an interesting part of the park history now. Now, another geologic feature that was a huge draw for tourists and for locals was the mineral springs of Alum Rock Park. And although the alum and the Alum Rock meteor are both kind of like fake faux stories, the mineral springs of Alum Rock Park are very real. There was at once known to be 27 separate springs at Alum Rock Park. And although when the park opened in 1870s, it wasn't right away known for its springs, but by 1890, it was nationally renowned as this wellness resort where people would travel to. They would take trains and cars and come to visit to soak in the healing waters of Alum Rock Park. There are hot and cold springs at Alum Rock Park, and these different springs have different minerals inside them, such as sulfur, soda springs, which is just carbon dioxide, magnesium oxide, and arsenic. And it was said that these pools would help with many afflictions, such as rheumatisms, also stomach aches, headaches, malaria, and all kinds of different sources, and all kinds of other afflictions. The mineral springs are not still open to this day, although you can see some of the beautiful stonework. A lot of the springs were dammed or plumbing was placed into them so they could create beautiful grottos and this amazing stonework. There was also water fountains where people could make use of the mineral springs. And at one point, there was even a huge indoor swimming pool of just a sulfur spring that people could come and enjoy. Now, this is a geologic feature of the park because of the way the underground geology of the park was formed. That is how these springs came to be. They are naturally occurring. They didn't just put in these minerals into this water. The waters draw the minerals from the earth. And now, again, you can't still use these. You can still go to Alum Rock Park and smell the sulfur coming from the springs, which is kind of a cool experience, but I do not recommend getting in the water. They are no longer maintained for people to swim in. So please don't. That would be a bummer. There's a lot of other beautiful things to enjoy about this park. So my question when I visited Alum Rock Park, there's a lot of amazing things to look at, but the smell of the mineral springs is hard to mistake. And I remember thinking, why are there hot springs at Alum Rock Park? I mean, it seemed so strange to me that there'd like randomly be these hot springs. I know there are hot springs down in Gilroy, down in Santa Cruz or Big Sur, but in Alum Rock Park by San Jose, it just seems so strange to me. But it was still a huge draw for people. Understand how the mineral springs got there and why they work the way they do. We're gonna have to take a few steps backwards and talk about how did Alum Rock Park exist? How did it come to be in San Jose? And to do this, we're going to have to take a little trip back in time. Oh, first, we're going to talk about the Diablo Mountain Range. So the Diablo Mountain Range is where Alum Rock is the mountain range that Alum Rock Park is a part of. The Diablo Mountain Range is about 1 million acres of land. There's oak trees, there's grasslands, and in this map from, say, Mount Diablo, you can actually see all of the different protected lands within the Diablo Mountain Range, which is really cool because this is a vital piece of habitat for many animals. And there's a huge effort to save and preserve a lot of the Diablo Mountain Range so that it can continue to stay as animal habitat and plant habitat. Alum Rock Park in this map is kind of hard to point out because it is so small in comparison to the rest of the Diablo Mountain Range, but you're gonna find it in one of those little orange chunks kind of to the bottom left of the Diablo Mountain Range. In the bottom left of this map, you can see the Santa Cruz Mountains, and just above that, you can see a little dot that says San Jose. So that's where I am right now. I am in San Jose, California. And then right above that, you'll see another little orange blip, and that's going to be Alum Rock Park and Sierra Vista Open Space Preserve. So the question, to understand how Alum Rock got here and understand why it's here and why it works the way it does, we have to understand how the Diablo Mountain Range was formed. In fact, we have to understand how all of California was formed and how it got its mountain ranges in the first place. And to do that, we have to take a trip back in time. So let's go. So the story begins, well, not necessarily begins, but this is where we're going to start. About 140 million years ago. This is during the late Jurassic era. The T-Rex is the main predator. It is damp, it is swampy. There is all kinds of dinosaurs running around. The ancestor of the redwood tree, survives across the North American continent. It's a crazy time. And California doesn't even really exist yet. You may know of the North American plate and the Pacific plate, but back in the Jurassic era, it was the Farallon plate that was interacting with the North American plate. In case you don't know what I'm talking about with all these plates, tectonic plates are these chunks of Earth's crust that kind of float on top of the mantle. And the mantle is all of this lava that lies beneath the Earth's crust. The Earth's crust can be, 5 to 20 miles thick. We've got about 5 to 20 miles of soil and rock between us and the mantle. And as those tectonic plates interact with each other and sometimes crash into each other, that is how we get new landmass formations. Specifically, what was happening in the late Jurassic area was the Farallon plate was meeting the North American plate, but they weren't equally matched. So the Farallon plate would scoot underneath the North American plate and get shoved down into the magma of the Earth. And that is called something called subduction. Now, I know this diagram looks a little messy. Don't be afraid. I'm going to walk you through it. So at the very bottom, you'll see this big orange block. And that's the mantle. That is hot, molten lava. It is thousands of degrees Fahrenheit. It's under a lot of pressure, and some weird stuff goes on there. That's where we get our really cool minerals and rocks. The green stripe you see going across this picture is called the lithosphere. That in your brain should be the Farallon plate. That is the plate, the tectonic plate that exists out in the ocean. To the right, you'll see a little mountain called the Sierra Arc. This was how the Sierras were formed. The Farallon plate dove underneath the North American plate. And as that happened, the North American plate lifted up a little bit. And as the Farallon plate dove into the mantle, into the magma, it started to melt. It got really melty and kind of started to float up, which helped build the Sierra Nevadas. Now, there was also this really interesting thing happening here called the Franciscan complex, which is the kind of blue swirly image in the very middle of the screen. This was kind of interesting geologically because as the Farallon plate dove underneath the North American plate, got all melty, the North American plate also just like peeled the very surface of the Farallon plate up. So all of that, the top of the Farallon plate that was all ocean sediments and layers of sand and fallen debris and skeletons from different animals that had died, that got just peeled up as the North American plate dove on top of the Farallon plate. At the same time, there was a bunch of magma coming into that like peeled area of ocean surface. And it was just getting tumbled and heated by magma and pressed upon by the North American plate and squished. And there was all this ocean water also coming into it. It was rich with so many minerals and nutrients. And it just kept getting rolled and heated and squished and with water. And it was kind of this, it created this really interesting geologic pocket. Now you can kind of imagine the Franciscan complex is really similar to if you had like one of those little Hershey's bars, you know, like one of those little Hershey's bar of candy, and then you put it in your pocket and then you forgot about it. And then you like went on a jog. And so that Hershey's bar is in your pocket, it's getting squished, it's getting mangled, it's getting all melty, getting kind of like weird and like kind of damp. And then you come home and you take it out of your pocket and you undo the wrapper. And it's, you know, it's not recognizable as a Hershey's bar anymore. You can't even see the logo. It's just like this weird melted kind of form. You're not even really sure if you can call it chocolate anymore. That's what's happening in the Franciscan complex. All of that rock and sediment is getting squished and melted and pressurized. And once the Farallon plate, essentially the Farallon plate gets almost entirely eaten by the North American plate. It gets completely just eaten up. And so that's when the Franciscan complex finally has time to relax and has time to solidify. And then it comes the Pacific plate. Finally, the Pacific plate allows the coast of California to rise up. It creates more mountains, and that's how we get the Diablo mountain range. So it's filled with all kinds of these really cool geologic components, all kinds of cool rocks, all kinds of minerals. Remember, it's just a weird melted Hershey's bar. And although that doesn't sound appealing to you, geologically speaking, there's some really unique properties about the Franciscan complex. Hopefully everyone tracked. Feel free to drop a question in the Q&A. In fact, maybe I'll take a break and see. No, we're good. Okay, if you have questions about the Franciscan complex, feel free to shout it out. Oh, there are also some other words on the screen, such as chert, limestone, pillow basalt, shale, serpentinite. We're going to talk about more of those later on. But basically, those are some of the minerals that are at play here and are created because of the Farallon plate subducting under the North American plate. All right. Come on, slides, you can do it. You can do it. There we go. Oh, go back. All right. So in modern day Alum Rock Park, as you go hiking, here are some of the rocks that you can see in the park because of this Franciscan complex, this melted chocolate bar rising to the surface. To the far left, you'll see some ribbon chert. This is evidence of layers and layers of ocean sediment getting pressed and twisted. These are all the layers of ocean sediments that were once underwater for millions of years and have now solidified and been pushed up into these hills. And you can see this. There's a great example of this if you drive all the way to the Mineral Springs parking lot and park and walk past that, that first gate area to the first hiking trails. You can start to see some of these linings and ribbons. In the center, you can see a rock that's actually this fossilized seashells. If you look at the white markings, those are actually all seashells that have been all stacked together and solidified. That is again from the ocean sediments many, many years ago that are now rocks at Alum Rock Park. There are great places to see this in Penitencia Creek. You can also see this all the way up in the hilltops at Sierra Vista Open Space Preserve along the trails. So I love this rock. I love that this is just like undeniable proof that sea critters used to live on the land that we walk on today. Now to the right is a rock called chert. I actually have some here with me right now. It's kind of this reddish brown rock usually, but you can also often find it where it's completely black or mostly white. Now you can think of chert as actually very similar to the rock in the middle where it's all those seashells all fossilized together. But chert are the fossilized skeletons, so the fossilized silicone shells of organisms that were microscopic. So we wouldn't be able to see them with our eye, not like we can see like an oyster or a clam. But chert is still that very same thing. All of those microscopic organisms, their skeletons floated down to the bottom of the sea floor. And as that tectonic plate subducted underneath the North American plate, it got pressurized and heated and fossilized until it became chert and rock. Now, these organisms would have been much smaller than, of course, the seashells that you see in the middle photo. And so this takes much longer to form. Millions of animals, millions of years have piled together, even in this just one rock, to create this chunk of chert. You can find chert at Alum Rock Park, and it's really cool when you do, because again, it's just such an amazing remembrance of all of the animals that have come before us and lived still in this park. Another cool rock you can find is serpentinite. There isn't a ton of serpentinite at Alum Rock Park, but you can find it throughout the Diablo Mountain Range. Serpentinite is often found, it's like a little green, as a shiny green rock. There's different lines of this white texture going through it, and that's actually asbestos. Asbestos, when airborne, can be very bad for you, but when it's solidified in rock form, like I have here, and as you can see in the picture, it is totally harmless. As long as you don't, sniff the rock too much or try to eat it or anything, you are good. Or mine it. Mining it would not be the stuff. But once upon a time, serpentine was mined in many places in the Diablo Mountain Range so that they could get the asbestos from the rock. It was also often mined in the Diablo Mountain Range as people looked for magnesite. Magnesite is another type of rock that is often formed around serpentine. This was really valuable for lime kilns because it has a high heat tolerance. It's kind of like white cauliflower looking rock. But anyways, serpentine is actually known as the state rock. And this happened when that the Farallon plate subducted under the North American plate, and a lot of water got into this rock and a lot of minerals formed, and it kind of found its way all the way up to the top of the Diablo mountain range. This mineral is also really interesting because it can create a really unique soil composition. In other areas of the Diablo mountain range, such as Coyote Ridge Open Space Preserve, there's plentiful serpentine in the soil. And serpentine actually makes the soil nutrition really low. It's actually really poor soil. But that's actually a really good thing because a lot of California native plants have adapted to thrive in serpentine soils where there's no nutrition. And so you can actually find a lot of really unique and now endangered plants in serpentine soils. So serpentine makes bad soil, but that's a good thing. So it's great that you can actually find some at Alum Rock Park. Oh yes, and again, we are recording this presentation. So you will be able to review it. Or if you came in late, you'll be able to see the beginning of it. I really like serpentine because it's pretty identifiable in the field. I feel like it's a really unique mineral, unique to California especially. And it's just this nice, smooth, shiny green rock. And if you aren't really sure, there's a few other different green rocks that can be found in the Franciscan complex. Serpentinite has a really high, dense, heavy metal content. And so if you were to put something magnetized to it, it'll stick. And so that's one kind of telltale sign of serpentine. It's magnetic. Oh, I have a question of where in Alum Rock Park can you find serpentinite rock? It is kind of few and far between. You'll find little chunks here and there along Penitencia Creek. It doesn't have, like serpentine soil like somewhere that Coyote Ridge would, but you can find little bits and chunks of it here and there. I don't have like a specific spot in Alum Rock Park where you can find it though. But I've come across it every once in a while. Dude. Yeah, come on, go to the next slide now. There we go. So as we come back, what about the mineral springs? What created the mineral springs and why are they there? So mineral springs are a geologic feature. They're also a water feature. Basically what happens is water from rain or from the creek will soak down into the groundwater. And remember, the hills of the Diablo mountain range, Alum Rock Park, are filled with all kinds of cool, unique minerals. And as that groundwater kind of sits through and shifts through the rock, it also collects and pulls in all of those minerals. And it stores them in pools of groundwater. The springs at Alum Rock Park are naturally occurring. Although piping and plumbing has been added so that the springs are more prevalent, they are just naturally there. They also have this interesting habit of creating limestone formations. So kind of as you can see in this picture, you can see the bottom of the spring is kind of eroding away. It's not just the normal stonework that you see at the very top of the spring, but down towards the bottom, you see kind of this clay looking buildup. That's small beginnings of limestone. As the springs put out all of their minerals, the minerals actually get caught on the stone and they start to build up. So you can get some really interesting buildup of, stalactites and stalagmites actually at Alum Rock Park. It's really cool. Here you can see a diagram of groundwater flowing through the different layers of the earth, and it picks up all of those minerals as it goes along. What's also really interesting is that there are hot springs at Alum Rock Park. A hot spring is anything that is warmer than the average human body temperature. So 98 degrees, 99, 100, those are all considered hot springs. Obviously not as hot as, what you can find at the Gilroy Hot Springs, Big Sur, or in Yellowstone, of course, but they do have hot springs. And I think that is especially interesting because hot springs occur when groundwater actually comes really close to magma and lava underneath Earth's surface. And then all of that heat travels up and up and up all the way to the surface. So not only are there mineral springs at Alum Rock Park, but there are hot springs. This is interesting because that means that magma might be actually closer to the surface at Alum Rock Park than we think. Although it's not actually that surprising to learn, especially when you look at the fault lines surrounding Alum Rock Park. This is a little map of some of the fault lines surrounding Alum Rock Park. Here you can see Alum Rock Park with a nice big star right in the middle of the screen. It isn't that close to the San Andreas Fault, but it is directly between the Calaveras Fault line and the Hayward Fault line. So fault lines occur when, as I talked about earlier, tectonic plates interact with each other. And the San Andreas Fault line is where the North American plate and the Pacific plate meet together. The San Andreas Fault line is very well known. It's huge. It spans across the entire Pacific Ocean. But fault lines like the Calaveras Fault line and the Hayward Fault line are much smaller. Those are more like reactionary fractures within the North American plate, because as the Pacific plate and the North American plate constantly interact over millions of years, they both kind of start to break and fracture along their edges. So that's how we get fault lines like the Calaveras Fault line and the Hayward Fault line. And magma can still kind of interact and bubble up through these fault lines. And Alum Rock Park is right in the middle of those two fault lines. The Bay Area is actually covered in fault lines, as you can see in this picture. There's not just the Calaveras and the Hayward Fault line. There's the San Gregorio Fault line, the Greenfield Fault line, the Concord Green Valley Fault line, and many others in the Bay Area. It's a kind of a little hodgepodge patchwork of fault lines. Let's see if we have a question. Oh, yes, what is a fault line? Cool, I already answered that. So yes, those fault lines are just basically cracks as those two different plates come together and they rub and they subduct and they push each other. They're just different cracks within the plates. And magma and geologic features can occur through those fault lines. A lot of people used to believe that there was actually a fault line running through Alum Rock Park. Many people have disagreed with this, though. Penitencia Creek runs through Alum Rock Park and has been a huge factor in erosion in Alum Rock Park through the years. And so it can kind of look like there might be a fault line there. But nonetheless, there are still fault lines very close to Alum Rock Park. So it's not surprising that these large stores of mineralized hard groundwater is getting heated by some source of magma. It's because those fault lines are there. Come on. Next slide. Now you may be wondering, wow, that's a lot of fault lines. Is Alum Rock Park safe? Are we gonna have crazy earthquakes? Although there hasn't been a ton of recent Alum Rock earthquakes, there has in the past been some recent geologic events that happened there. As we can see in the far left, that is another example of limestone building up as a result of the different springs. Many of the springs at Alum Rock Park over time have run dry, either from overuse or because the groundwater there has run out. And as those springs create buildup, they can actually plug themselves up too. So that limestone is going to continue to build as the Alum Rock springs continue to flow and continue to build on themselves. Back in 1989, El Nino winter storms ran through the park and caused huge flooding and landslides. And many trails had to be altered. This obviously altered the terrain of the park, what plants lived where. In 2007, there was about a 5-degree earthquake just 5 miles northeast of the park. And also there was heavy rainstorms in the winter of 2017 that also caused landslides and caused park closure. Although, you know, these aren't earthquakes that are completely changing the park. These instances of erosion and mineral buildup and small earthquakes do still change the park over time. I think a lot of times make the mistake of believing that geology takes place over the course of millions of years. We don't really see its effects in our lifetimes. But the truth is, our parks and the lands that we love are changing constantly. And I think as people who enjoy the lands and enjoy the parks, it's up to us to care for and steward them and remember and appreciate the changes that they've gone through. The park isn't just there magically, it was specifically formed with really unique features. And as we enjoy the parks, I think it's easy for us to forget the journey that it's been through and just accept it for how it is. But the truth is, the next generation could know a different Alum Rock Park with different trails, all because of geologic events and erosion that have happened there. This is a picture of some of our trail masters. These are all volunteers with the Open Space Authority who help to build and reinforce trails at Alum Rock Park and at other parks and nature preserves across San Jose. The city of San Jose also has amazing staff and amazing volunteers, which help to support the park as well. If you are interested in helping to protect the park and remember the changes it's been through, we are always looking for new volunteers, and so is the city. In fact, there are a ton of other environmental organizations who love to protect the land. And if you're interested in volunteering with them as maybe helping with trail maintenance or helping do educational programs like I am, there's so many amazing opportunities for whatever you're interested in. So with that, that's all I got. This is a very old drawing of Alum Rock Park. You can see the old school grotto of the mineral springs. And if you guys have any questions, I would love to answer them. Yay. I can also bring back up those rock samples that I had if you guys would like. Or I can go back to any slides you guys had questions about or anything like that. Oh, I also wanted to say, first of all, thank you for joining me for this program. Geology is I'm obviously not a geologist, but I do really enjoy geology. It's like a fun side habit for me. These rocks are educational tools for the Open Space Authority. I don't just go and collect rocks, although I do have a rock collection. If you also have a rock collection, I recommend you buy rocks from different rock shops or visitor centers. It is a great way to help support parks and local businesses without also adding to erosion in the parks. All right, we got some questions. Oh, yes, there was a train running through Alum Rock Park back in the late 1800s, early 1900s. And that was because it became so popular while the mineral springs were nationally recognized that they built a train straight into the park. You can actually still see the train railways and the bridge the train would cross still at Alum Rock Park. It is, of course, no longer in use. You can drive into Alum Rock Park now, but yeah, back in the day, there was a train that came through there. We will be posting the recorded presentation on the Open Space YouTube channel about probably by this time next week. It should be up and available. I can send out the link to everyone who participated from your Eventbrite emails. So keep an eye out for that. I can send out the link to everybody. Yes, so here is the serpentine rock that I have. Try to get nice and up close. You can see it's pretty this one's a pretty rough example of serpentine, but even so, it's still kind of got some nice shine to it. It's this really beautiful deep green coloration. And again, these white lines that you see running through it are asbestos. So if you see serpentine and you also see some white chunks on it, don't start picking it off. or you know, licking it or smelling it too much, because that probably isn't good for you. I also have a sample of chert. Again, this is the fossilized skeletons of microscopic organisms from an ancient ocean. It's really, really cool. You can definitely find it at Alum Rock Park in Penitencia Creek. It'll just be this big block of like heavy, dense red stone. And of course, last but not least, the magnesite I have here. I didn't really talk much about it. You can't really find magnesite at Alum Rock Park. But like I said, you can find it in other parts of the Diablo Mountain Range, and it was mined in the Diablo Mountain Range. It has a high heat tolerance, and so it was used for supporting like blasting kilns. It's like this really like chalky, light, fluffy rock. Oh. I see a question here. Are there any plans to renovate or add new facilities or playground aspects to Alum Rock Park? Not that I know of. I know that trail maintenance basically happens there constantly because since it's in a canyon, gravity and water just constantly pull the soil down. But as for infrastructure, not that I know of. I know back in the day, like I said, there was these crazy grottos and swimming pools, but it seems that Alum Rock Park is definitely moving to more of a like a nature-oriented park rather than an attraction-oriented park. And I have a question. I've seen people collecting water from the springs at the park. Is that water safe to drink? No, it's not safe to drink. Don't drink it. Well, first of all, any freshwater source you see running through a park still has like animal bacteria in it and bugs in it and just, you know, nasty stuff in it, eggs. So don't drink that, period. But especially considering that the mineral springs are in there. I mean, probably back in the day when the facilities were intended for people to drink and swim in them, they probably kept those pools clean, but now they are not monitored, not in the way that they used to be. And so the possibility of bacteria growth or hurting yourself, there is arsenic in some of those mineral pools, and arsenic is bad for you. Don't drink it. You can definitely smell it. You can smell the springs, and that is a way you can enjoy them. You can even like feel the heat coming off from some of the springs, so you can still get a little bit of the spring experience. But yeah, I don't recommend you drink it. Definitely not untreated. I have a question. Will there be an in-person geology event? We did have an in-person geology event last month at Alum Rock Park, which was super fun. But if you're interested, we can certainly do more, especially since there are all kinds of parks around San Jose that are part of the Diablo Mountain Range and have resulted in this Franciscan complex, unique composition of minerals. As I said before, I'm not a geologist, but I do really like geology and rocks, so I will certainly be doing more programs in the future. Keep an eye out. You can probably get on a list for Alum Rock event mailing list, and you can certainly go to the Open Space Authority website and sign up for our event newsletter and get emails when new events come up. Yes. I have a question. Are there diamonds in Alum Rock Park? Not that I know of or anyone has found. Again, there was a lot of mining attempts for people tried to mine within Alum Rock Park or in the like adjoining areas and hillsides, and no facility was ever able to find enough minerals to make it worth the expensive mining operation. So people have tried, people have failed. So probably not any diamonds in Alum Rock Park, but I don't know. Let's keep the mystery alive. There might be. Another question about live geology walks. We had one last month. Again, there will definitely be more in the future. You can sign up for an emailing list. You can also go onto the city website to look at more events that are happening in Alum Rock Park. see a question. In Edgewood Park near Redwood City, there was a wonderful tiny plant called the mouse-eared I don't know what that last word is, but in serpentine soil. Is that plant found at Alum Rock Park? Oh, I'm not sure. I would say probably not, because again, Alum Rock Park definitely has chunks, probably like parts of serpentine within it. But for California native plants that live in serpentine soils to thrive, there needs to be a lot of it, and it needs to be pervasive throughout that land. So I would guess probably not, but again, I'm not sure. There very well could be. One way that might be interesting to find out is if you have iNaturalist, you can go on iNaturalist and see what plants have been identified at Alum Rock Park. Are there any attractions in Alum Rock Park now? There are tons of picnic tables, barbecue areas. There's a wonderful visitor center. There's playgrounds, there's volleyball nets. There's also the Youth Science Institute, which is a really cool organization. They have a facility at Alum Rock Park that you can go into, and they have all kinds of live animals, all kinds of stuffed animals, bones, and great staff that you can learn from. So in a lot of ways, those are all kind of still attractions at Alum Rock Park. And of course, they have really cool rocks there. They have a meteor. Go check it out. Oh, I have another question. I hear there's a waterfall at the park. I have also heard that there's a waterfall at Alum Rock Park, and I've hiked all of the trails and I've never seen a waterfall. I don't know if maybe because we've been in a drought, it's just been too dry for wherever that waterfall is running to run, but I've never seen it. Maybe back in the day it was, but since there has been kind of more recent landslides and erosion development, the waterfall just might not be there anymore. I'm not sure. Ooh, and then we have a comment. There's a lot of exposed chert in the cliffside of Sierra Vista Trail going east from the parking lot. Also, Santa Teresa Park has a lot of serpentinite along the Rocky Ridge Trail. It's very cool. Yes, I do think you're right about Sierra Vista. I have seen a lot of chert there before. I haven't explored much of Santa Teresa Park, but I believe you. The whole like Diablo mountain range and the Santa Cruz Mountains has some little pockets of serpentine in it. And it's really cool when you stumble across it. Oh, another question. Has there been any wildfires at Alum Rock Park in the past? I know that there have been fires in the park. I also know that the staff are really good about mitigating any fire danger in the park. I don't think like the whole park has ever been on fire. I know there have been little sections or little fires that have been started in the past, but nothing too damaging. As many of you might know, during this past week, because it's been so hot and dry, Alum Rock Park has actually been closed because of possible fire dangers. And so when fire danger is really high, they'll just close the park out of protection for the locals, protection for anyone who might be visiting the park, and also so that the park just has a chance to, heal on its own, maybe gain some moisture. Yes, thank you all so much for joining me during this talk. I had so much fun preparing for it and answering your questions. Yes, there are horseback ridings at Alum Rock Park. Not all of the trails are suitable for horseback riding, but there are certainly some. So take a horse out there. There's always a bunch of little kids at the park. It's such a great family park, and they would love to see a horse out there. But yeah, thank you all so much for joining me. I had a great time. Hopefully I get to see you in the park sometime soon or at one of the nature preserves that the Open Space Authority manages. So thank you all so much. I hope to see you again soon, and happy trails. Stay safe out there.